Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss some support reaction based problems. Now you can see in question number 1 we have a simply supported beam which is supported at points A and B. At point A we have hinge support and at point B we have roller support. Now between A and B there is a load of 5 kilonewton per meter which is UDL, and at point C we have 10 kilonewton point load. Now we have to find out the support reactions. So our first step will be to draw the free body diagram of this beam. Now since at point A we have hinge support, so we will draw one vertical reaction and one vertical reaction at point A, that is RAH and RAV. At point B we have roller support, so we will draw one vertical reaction RB. Now our second step is to convert the UDL into point load. So we can see that a UDL of 5 kilonewton per meter intensity is acting at 4 meter. So the total load will be 5 into 4, that is 20 kilonewton, and it will act at half of 4, that is at 2 meter. 2 meter from point B and 2 meter from point A. Now once the free body diagram is drawn, we will apply the conditions of equilibrium one by one. So our first equation is sigma fx equal to 0, that is sum of all horizontal forces equal to 0. You can see from the diagram that there is only one horizontal force which is RAH. So RAH is equal to 0. Our second equation, sum of all vertical forces equal to 0. So RAV plus RB minus 20 minus 10 equal to 0. RAV plus RB equal to 30 kilonewton. This is our second equation. Now third equation, sigma m equal to 0. So we can take the moment about that point at which maximum unknowns are acting. So they will become 0. So you can see that at point A we have RAH and RAV. So if we take moment about at point A, so moments of RAH and RAV will be 0 and we will get the value of RB. So take the moment about A point. RB will try to rotate the body in anti-clockwise direction, so its movement will be taken as positive. And 20 kilonewton and 10 kilonewton will try to rotate the body in clockwise direction, so their movements will be taken as negative. So movement of RB will be RB into 4 minus 20 into 2 minus 10 into 5 equal to 0. So RB equal to 22.5 kilonewton. Once the value of RB is known, we can put this value of RB in equation number 2. So we will get RAV equal to 30 minus 22.5. So RAV equal to 7.5 kilonewton. So this is how we will do this question. Now let's move to second question. You can see it is a cantilever beam. At between A and B there is a UDL of 5 kilonewton per meter, and between B and C there is a UVL of 10 kilonewton per meter, and at point C we have 10 kilonewton of point load. So our first step is to draw the free body diagram. You can see only one support is there, which is fixed support at point A. So we will have one vertical reaction, one horizontal reaction, and one movement at point A. So RAH, RAV and MA, these are the three unknowns. Then we will convert UDL and UVL into point loads. So 5 kilonewton per meter UDL will be converted into point load, and it will be 5 for the 20 kilonewton, which will act at half of 4, that is 2 meter. Similarly, 10 kilonewton per meter intensity of UVL acting at 6 meter. So it will be total load will be 1 by 2 base into height, that is 1 by 2 6 into 10. So 30 kilonewton will be total load, and it will act at 2/3 of 6 from the vertex, that is at 4 meter from the vertex C. So at point B, from point B it will be at 2 meter. Now once we have drawn the free body diagram, we can apply the conditions of equilibrium. First equation, sigma fx equal to 0. that will give you RAH equal to 0. Second equation, sigma Fy equal to 0, it will give you RAV minus 20 minus 30 minus 10 equal to 0. So RAV equal to 60 kilonewton. Now take moment about point A. So moment of RAH and RAV will be 0. MA is trying to rotate the body in clockwise direction. So minus MA, minus 20 into 2, minus 30 into 6, minus 10 into 10 equal to 0. So movement will be MA equal to minus 320 kilonewton meter. Minus sign indicates that the direction which we had assumed, actual direction is opposite to that. So we assumed MA in clockwise direction. Since answer is negative, so answer will be written as MA equal to 320 kilonewton meter anti-clockwise. This is how we will solve the problems related to cantilever beams. Now let's see question number 3. Again we have a cantilever beam. At point between point A and B we have UVL of 10 kilonewton per meter, and between B to C we have UDL of 5 kilonewton per meter. So first step is to convert the support, the free body diagram of support. Since it is a fixed support, so we'll have one vertical reaction and one horizontal reaction and one movement at point A, RAH, RAV and MA. Now we will convert the loads into point load. So 10 kilonewton per meter UVL acting at 6 meter, it will be, total load will be 1 by 2, 10 into 6, that is 30 kilonewton. It will act at 2/3 of 6 from point A, that is at 4 meter from point A, and at 2 meter from point B. Similarly, UDL will be 5 into 4, that is 20 kilonewton, and it will act at half of 4, that is at 2 meter from B and 2 meter from C. Now once the free body diagram is drawn, we will apply the conditions of equilibrium. First equation is sigma Fx equal to 0. So RAH will be 0. Second, sigma Fy equal to 0. So RAV minus 30 minus 20 equal to 0. RAV equal to 50 kilonewton. Now third equation, sigma MA equal to 0. We will take movement about point A. So movements of RAH and RAV will be 0. And minus MA, minus 30 into 4, minus 20 into 8 equal to 0. It will give you MA equal to minus 280 kilonewton meter. Again this minus sign indicates that the direction is opposite to what we assumed. So answer will be MA equal to 280 kilonewton meter anti-clockwise. Now let's see question number 4. This is again an overhanging beam. At point A we have hinge support, and at point B we have simple support. So we will draw the free body diagram of this beam. At A we will have one vertical reaction and one horizontal reaction, RAH and RAV, and at B we will have one vertical reaction, RB. Now once the free body diagram is drawn, we will apply the conditions of equilibrium. So applying first equilibrium equation, sigma Fx equal to 0, that is sum of all horizontal forces equal to 0. Since RAH is in positive x direction, so plus RAH equal to 0. It gives you first equation. Then second equation, sigma Fy equal to 0. So RAV plus RB minus 20 equal to 0. Only 3 vertical forces are there, RAV, RB and 20 kilonewton. So the equation will be RAV plus RB minus 20 equal to 0, or RAV plus RB equal to 20 kilonewton. Then third equation, sum of all movements equal to 0. So we will take the equation of movement about point A. So RAH and RAV's movement will be 0. RB will try to rotate the body in anti-clockwise direction, so movement will be positive. 20 kilonewton will try to rotate the body in clockwise direction, so its movement will be negative. And 20 kilonewton meter is already acting at point D, which is in anti-clockwise direction. So movements will be RB into 4 minus 20 into 6 plus 20 equal to 0. It will give you for RB equal to 100 or RB equal to 25 kilonewton. Now we will put this value of RB in equation number 2 and we will get RAV plus 25 equal to 20. So RAV equal to minus 5 kilonewton. Now this minus sign again indicates that the direction of force which we assumed in upward direction, that is not in upward direction but that is in downward direction. So answer will be RAV equal to 5 kilonewton in downward direction. This is how we can find out the support reaction in various types of beams. I hope you must have enjoyed the video. Okay, thank you everyone.